Hi, my name is Nikit, and today we'll be looking at the geomagnetic storm influence on the SWARM space mission. So the SWARM constellation consists of three identical spacecraft which study the Earth's magnetic field and investigate the Earth's upper atmosphere. The constellation was launched in 2013, and the spacecraft fly in a low Earth near-polar orbit. On August 25th to 26th in 2018, a geomagnetic storm occurred, classified by a KP index of 7, giving it a major storm status. The KP index relates to the degree of magnetic disturbances and functions like the Richter scale for earthquakes. We see disturbances of the storm towards the end of August 25th to the 26th, characterized by significant spikes in all of SWARM's electromagnetic measurements. Specifically, we see the magnetic field intensities and electrical currents to be 5 times larger during the storm. While we easily see the results of the storm in SWARM's electromagnetic measurements, we researched to see the impact of this storm in the accelerometer measurement disturbances. From the graph, we can see that the accelerometer or ACC measurements in red from SWARM C are highly disturbed during the storm. The ACC data frequency components are dominated by a periodic component that occur every time the satellite completes one orbit and one half orbit around the Earth. To understand the geomagnetic influence on SWARM's ACC, we remove these dominant orbital periodicities. Next, a low-pass filter via a Gaussian kernel is employed to smooth higher frequency components as seen in blue. High-resolution understanding of non-gravitational accelerations of spacecraft is essential. Knowledge of these effects which disturb satellite trajectory is vital for precise orbit prediction. Furthermore, spacecraft non-gravitational accelerations are subtracted from gravitational ones to construct gravity field maps of the Earth, an important scientific objective which allows us to understand mass movement on Earth. SWARM's ACC considers effects such as solar radiation pressure and atmospheric drag quite well, but the understanding of the electromagnetic influence is very slim and theoretical. We performed the analysis from August 23rd to 29th to understand the geomagnetic effect on quiet and storm days. As SWARM's electromagnetic data in mid-latitudes show significant complications, we separated polar northern and polar southern hemispheric tracks. From SWARM's data products, we calculated a pointing vector showing the flow of electromagnetic field energy. To understand signal frequency information localized in time, we performed a rigorous track-by-track wavelet analysis on SWARM's ACC, pointing vector, and electromagnetic data in different bandwidths of interest. Based on what we saw in the wavelet analysis, the cross-wavelet analysis was performed between the ACC and the pointing vector to see the electromagnetic influence in the ACC disturbances by investigating coherency in the two signals. On top, we have a time series of the accelerometer data in blue versus the pointing vector in green in the x direction for the northern hemisphere on August 23rd. Beneath, we have a spectrogram showing a cross-wavelet analysis to investigate coherency between these two signals. The cyclic frequency, or the y-axis of the spectrogram, shows the bandwidth of frequencies for which we investigate coherency. The x-axis is time and matches to scale of the time series. At 430 seconds, we see high coherence between these two signals. The phased arrows indicate that the pointing vector leads the ACC disturbances. This is really fascinating. It shows that as SWARM C traverses from the ascending to descending track, there's a periodic component and frequency of about 0.1 in the ACC attributed to the electromagnetic influence. We are seeing this component consistently in SWARM's ACC for tracks on quiet days. Analyzing hundreds of spectrograms, we are investigating the electromagnetic impact on ACC measurements. We have seen strong coherence between the accelerometer data and the pointing vector. We are observing the effect of the electromagnetic disturbance in ACC measurements at higher frequencies in quiet days. During the storm, early stages indicate this effect is at a much lower frequency. In this research, I have presented a rigid analysis to quantify the electromagnetic effect in the ACC by use of novel spacecraft data products. Track by track, this research indicates we are on course to understanding the geomagnetic effect on the SWARM space mission. We look forward to further work on this field of study. Thank you very much for listening.